Ellie, and I'm one of the lab instructors for our stats class this semester. And I'm going to show you guys how to create a histogram and a bar graph in JAMOVI. So for this, you're going to need two different files. This first file, the Gapminder file, you should have downloaded for our very first class. And then up here is the film permits file. So I'm going to jump over to the Gapminder file. So for this data set, you were asked to answer what the average life expectancy is. So this means that we are going to be looking at this variable here. And to answer this question, we are going to want to look at the entire distribution. We're not comparing different countries or different years or anything like that. So when we want to look at the whole distribution and compare all of it together, we are going to want a histogram. So to create a histogram, we are going to go to the Exploration tab, go down to Descriptives, and JAMOVI is very nice. It automatically wants to create a chart for you, but we don't want that chart right now. So I'm going to uncheck all of these boxes so that we have a blank slate. I'm going to move our life expectancy variable over here, go down under plots and click histogram. So again, we are looking at the whole distribution of our data, which means that we aren't looking at real numbers. We can see on our y-axis that we have density, which means that we aren't looking at the most life expectancy or the highest life expectancy. We instead are looking at different intervals of life expectancy brackets that JAMOVI has created for us. And these little columns tell us how many people are in which bracket or interval. So, or maybe I shouldn't even say how many because we don't have real numbers here, but it tells us which has the most amount of people and which has the least amount of people. But again, we are looking in ratios here. We're looking at it relative to one another, no real numbers. So looking at this distribution, we can see that it's sort of normal. We have this really big spike over here around the maybe 70 to 72 interval where we have a lot of people in this life expectancy here, or a lot of instances of this life expectancy. So we could be easily fooled and think that this would be our average. But what we'd be missing here is that this data set skews a little to the left. We can see it has a little bit of a pull. So this means that wherever we can see this little, or this highest spike, we also want to move our prediction over to the left. So if I were to predict the average life expectancy, it would be around the 60 mark. We can double check this by checking this mean box under central tendency. Yep, we can see that the average life expectancy here is 59.5. So this is how we use a histogram to answer a question like finding the average life expectancy. And just as a reminder, we use histograms to look at ratio and interval scales of measurement, meaning that we are not working with real numbers on our y-axis. So now we can jump over to our film permits data set, where we want to answer the question of which borough has the most film permits. So when we say most, that sort of is a cue that we're looking for a comparison. And when we say which borough, it tells us, we are looking to compare variables, nominal variables, which borough, not numbers of boroughs, but which borough. So just like before, we are going to go over to the Exploration tab, go down to Descriptives. It is, again, trying to make a little chart for us. Maybe this is just me, but I like a clean slate. We'll move our borough variable over so that it knows that this is what we want to look at. Go down to Plots and click Bar Plot. So again, we are working with nominal data here. We can see the names of each of the different boroughs. And our question is pretty easily answered. We can see which borough has the most film permits. And if we look over at our y-axis, we can see that we're working with real numbers again. We can see that Manhattan has the most film permits at just about 25,000. And then from there, we can go down the list. The next highest bar is Brooklyn, then Queens, then Bronx, and then Staten Island. So again, we use a bar graph for nominal and ordinal scales of measurement to make comparisons with real numbers. Now, if you have any questions on any of what I've gone over just now, please either bring it up to your lab instructors in our synchronous meetings, or you're welcome to post any sort of questions on your lab discussion board, and this will help the other students in your class to get the same information and get those questions answered too.